Let's at least begin to build a vector class in Python. We're going to build our vector class from scratch so that we can have a better understanding of how vectors work. Then when we use this class in another program, we're better in control of what we want to do, which methods do we want to apply, and exactly how do we want to implement things. So we don't need it at this point, but we will later. So let's go ahead and import math and then start to build our vector class. So we start with the constructor, and in the constructor, we're going to have a set of values or a list of values that correspond to the components of the vector. And so this list of values will be a list or tuple of ints or floats, and we're going to then convert everything to floats, again for some of the reasons in the future, but we'll just do that at this point in the constructor. So we start off with a list, an empty list that contains the data of our instance of the vector class. And we will go through each of the values, and if that value is an int or a float, then we will append it to self.data, but we will only do that appending after we've converted the value to a float. So if it was an int, we go ahead and convert it to a float. Of course, if it's a float, it will remain a float. If one of the values is not an int or a float, then we want to raise a type error. We don't want our vectors to have strings or other things included. And then the dimension of the vector will be the number of entries, the number of values that we're given. And so we can get that attribute by finding the length of the list self.data now that we have filled all the values in place. This does work. The only problem is we have to create a vector by, first of all, creating a list or a tuple. Let's say we want to look at the vector 1, 2, 3. We would either create a list or a tuple, and then create our vector by calling the vector class on that list. We could do that, or we could, in the parentheses, when we create the vector, we would put the values as 1, 2, 3 in a list, or we could put that as a tuple. But what we really want to do is we want to be able to write this as just vector 1, 2, 3, make it easier to work with. And that way we don't forget to put the parentheses or don't forget to put the square brackets. And so the approach that we have doesn't give us this in terms of being able to enter the data. What we have requires us to either create a list or a tuple and send that to the vector class. All right, so what we can do, everything being the same so far, is rather than setting values, we could use the asterisk, the star here, which is the unpacking operator. And so what happens then, rather than requiring a list or a tuple, this gives us a variable length argument. So just how many ever values that the user puts in when they call the vector class, how many ever values are there, are then unpacked into a tuple, and that can be used going forward. So what happens if we make that one change, then everything else is exactly the same. We don't need to change anything else. It just allows us to enter the values as, say, vector 1, 2, 3, rather than creating a list or a tuple. So the unpacking operator allows us to have an arbitrary or a changeable number of inputs at different times. And so often if you see this somewhere else, the input is using the unpacking operator has the variable name or the parameter name of args for arguments, but that's just a name, and so we can do anything that we like that's appropriate for the context. So if you want to use args, that's perfectly fine. Again, that's what you see often in examples, but it can be any name. It's the star, it's the asterisk, right? The unpacking operator that matters most here. If we have keyword arguments, so things named by, there's a name and a value, then 2 asterisks, and that's often called KW args or keyword args. But again, that's just a name. It just emphasizes that we're talking about something that's given by a keyword rather than just having a standalone value. We'll come back to that later, talk about it in some other contexts when we have to assign values according to the name of what they represent. Okay, so something we would like to be able to do with our vector class would be to access the attributes by index. And so we have, say, a 10-dimensional vector, then we might want to be able to access the 5th component or some other components. And so to be able to access by index, we have the method getItem. Again, remember that the double underscores around the name correspond to methods that we usually don't call by name. We use those methods usually in the context of overloading an operator. And in this case, the way we call this method will be using the brackets in Python. So for getItem, we will have an index, which is an integer index. If we go out of range, then we will get the Python error for index out of range. We could create our own error if we like. And what we will return is the value at that index. And so to do this, all we have to do is access the list that contains the information, that contains the data, which is self.data, and use the square brackets and the index corresponding to the value that was given by the user, and return that. And we have now allowed ourselves, if we create a vector, let's say we create new vector earlier, we could say new vector square bracket 0, and in that example, since the vector was the vector 1, 2, 3, we would get back the value 1. So getting items is good, but being able to change those values, and this is set item. So with set item, what would you have to do? You would have to give an index and then a value. And so again, we have the index that we need to update. We have the new value that we want to put in, which again should be an int or a float. And we want to update self.data by putting in the correct value. We do need to check to see if it's an int or a float. If it's not, then we can raise an error. If it is an int, then we want to convert it to a float. If it's a float, again, we can still convert it. It's not really converting, but it doesn't change anything. We can have that line in the method. But in this case, you get to replace pass with your attempt at writing this method. As usual, if you have any questions, let me know. In terms of vectors, what we've done so far, again, we've left out a lot of features, adding, subtracting, multiplying by scalars, and so on, that we will be able to do based on hopefully previous work that we've done together. But if not, again, we will get there. Make your best effort to write those other methods to be able to create a vector class that can add, subtract, multiply by a scalar, multiplying on the left or the right by the scalar. And then we will add some other features to this class as we go along, things like dot products and cross product for three-dimensional vectors and other features that we will need in implementing using our vector class, especially in the context of Pygame. So one thing that we want to look at is being able to now focus our general vector class that can have any dimension to things that are specific to 2 or 3 dimensions. So we will focus on the 2-dimensional case, and then you can complete this in 2-dimensional case and then complete the 3-dimensional case, which would be very similar in what's going on. Now, in our constructor for the vector class, we did leave out any mention of a vector 2 or a vector 3 class. And so there's some missing things from the constructor that you will want to go back and add a bit later. So we could, in the same module, in the same vector module, but outside the vector class. So this is a separate class in that same module. We can create a vector 2 class, and here we want to use inheritance. So in the parentheses, we will use vector. We will inherit everything from the vector class and then add some specific things that are appropriate just for vector 2. And so our constructor in this case, when we want to create a vector 2, we can specify there are just 2 values, an x and a y. And again, this x and y value need to be an int or a float that we will convert to float. And what we're going to return in this case is a vector instance. Again, it's not really returning because the constructor doesn't really return something, but it will create a vector instance that is both a vector and a vector 2. And we can do this in one line. We can call the constructor for the superclass, and the superclass in this case is the vector class. And so we will call the constructor for the vector class to create our vector 2. One thing that we want to be able to do is to be able to do things like in a vector, especially a 2-dimensional vector, we want to talk about x and y a lot. So if we had new vector, we would want to be able to talk about like new vector dot x. And so we can use a feature of Python that allows us to, in a sense, mimic what other languages do with having private variables and public variables and so on. But in our case, in Python, everything is public, but we would like to not have to worry about self.data that can be behind the scenes. And so we would like to be able to, with a vector, just be able to talk about the x coordinate. And so this idea of a property, which we create by putting in a line that says at property right before we begin or define a function. And we can define this function to be called x. We have a vector 2 instance, and it's going to return the x component. Well, what is the x component? That is the value that's in position 0. And so we can return self bracket 0. We're allowed to use this now because we have created our getItem method already. We don't need to do self.data 0. We can do self 0, although self.data would work in this case. But since we've already created the other method, we might as well go ahead and use it. Now, there are several ways to do this. Lots of other ways to access this information, but this is a way that we're going to use for other things, and so I wanted to show it in this context. What's the idea if we have to get a value, even if we have to calculate a value sometimes, but we want it to feel more like an attribute rather than a function call? We can create a property, and that will calculate the value, but then we can access it just with, say, in this example, new vector.x to get that value. So the property is a nice feature, a nice way to be able to access values. If the value does require a lot of calculation, it's probably better to make sure that it stays as a regular function call so that the user knows that it's not an immediate value, that there's some overhead associated with it. But often things that don't require lots of calculation, we can just give it a name and use this feature to be able to call that value. Now, the other thing that would happen if we created or we can access the x value, what if we decide we want to change the x value? And with changing the x value, there's setter properties as well. And since we called our function x, now we want the x.setter. So we have at x.setter. And now we're going to define a function x that has different parameters. We just created a function a moment ago that had one parameter of self, and now we've created another function that's called x that has a different set of parameters. It's self and new value. Now the thing is that it's not really the same function. It looks like the same name, but the property and the setter, there's some things going on behind the scenes that we can talk about a little bit later. But what this will do is allow us to have an instance of a vector2 class and then a value that we want to change the x to. So we want to change the x value to the new value. And so again, if that new value is an int or a float, then we can change the value. We could also have done self.x right here. But the idea at this point, and that's how we would use it outside. We can't do that here because we haven't defined doing that yet. But what we can do at this point is change the value of self 0 to the new value. So then when we use that, we would say something like new vector.x equals 7, and that would change the 1 to a 7. Actually, it would change 1.0 to 7.0 because we are turning things into floats. Otherwise, we would want to raise a type error that says that only ints or floats are acceptable at this point. All right, so there's a lot more to do in adding to the vector class. The general vector class, the vector2 class, and the vector3 class. But most of those pieces, most of those components we have talked about. And so as usual, if you have any questions, then find me on Discord or send an email, or you can comment below.